Chapter 5 is all about financial applications and models. We'll start off in a gentle format with section 5.1 on compound interest, part 1. So the first question really is, what is simple interest? So before we can talk about compound interest, let's ask about what simple interest is. So what is simple interest? So simple interest, basically your money is deposited into an account and it just sits there and does absolutely nothing. When you go to withdraw it or take it out, or at the end of the time, then the interest is calculated and added in and given back to you. So that's what simple interest is. The money does nothing. At the end of time, the interest is calculated, added on, and returned as a lump sum to you. So the formula for simple interest is simply the interest earned I is the interest earned, that's equal to P times R times T, where P is your principal. That's the amount that you invested, so that's the beginning amount, or amount that you put into a deposit. R is the interest rate, always as a decimal. And then T is time, and it needs to be in years. So this will let us calculate how much interest your money has accrued or earned during a specific amount of time at a specific rate of interest. And if you want to find the total account or total amount of money in the account, you look at the accumulated amount. And that formula would be A for the accumulated amount equals P, still the principal, 1 plus R times T. So this is taking the initial interest that's added on, which is the PRT plus the initial principal, and adding it on. So the A is the accumulated amount, or the amount at the end. So let's walk through a really simple one just to get some familiarity with the words. So example 1 says, find the simple interest on a $500 investment made for 2 years at a rate of 8% per year. And what's the accumulated amount? So let's go ahead and identify all our variables. So P is the principal, that's how much money we're investing, which is $500. R is our interest rate, which is 8% per year. So as a decimal, that would be 0.08. And T is the number of years, which in this case is for 2 years. So the interest that we're going to earn on our account is our principal of 500 multiplied by our interest rate of 0.08 multiplied by our time of 2. Simple plug and chug. This should come out to be $80. Now that's the interest earned. So this is the amount in interest. So again, what that really represents is you've left your money in an account. The bank can use your money, and for the privilege of using their money, they pay you interest, and that's what that is. Now the accumulated amount, I can go back and rework the formula, but I can also recognize that I initially deposited 500. I earned $80 in interest, so the accumulated amount at the end of time is 580, and that would be the same thing we would get if we come in and use this formula. Let's try another one. So example 2, a bank deposit paying simple interest at the rate of 6% per year grew to a sum of $7,200 in 9 months. Find the principal. So we know that the amount at the end of the time was $7,200. The rate of interest was 6% per year, so 0.06. Grew to, and that was in 9 months, so T would be 9 over 12, which is 0.75 of a year. And we're trying to find P, so how much did we deposit in the beginning in order to have 7,200 after the 9 months? So we'll go back and use the accumulated formula. So A equals P times 1 plus RT. And I know to use this because we're given the accumulated amount, or the amount at the end of time. That's the 7,200. That'll equal to our principal plus 0.075. Oops, sorry, let's put it in the correct order. So our rate of interest, which was 0.06. Times the 0.075. 0.75. Got too many decimals floating around here. So algebraically, if we're going to solve this for P P is going to be equal to 7,200 all over 1 plus the 0.06 times the 0.75. When you go to do this in your calculator, you can do it all in one lump sum, but make sure you get the denominator instead of parentheses. Otherwise, your calculator will divide by the 1 and then add the other parts back in. And if you do that, the principal should be equal to $6,889 and $95.95. So this is saying if we deposit $6,889.95 into account after 9 months, it will have grown to $7,200 at a 6% interest. One more simple interest problem. This is example 3 on the handout. Example 3 says, determine the simple interest rate at which $1,200 will grow to $1,250 in 8 months. So this time we're looking for the rate. So we've been identifying different unknowns. This time the rate is the unknown. So R is equal to question mark. We know that the initial amount is the $1,200. It's always the smaller of the $2 amounts. The final amount that it grew to was $1,250. And that was in 8 months. So that would be 8/12, which is the same thing as 2/3. Notice that I'm not taking that to a decimal because it's a repeating decimal. So I'll let the calculator handle that repeating decimal into things. So we're going to have A equals P times 1 plus RT. Same formula again because they gave me the accumulated amount at the end. So 1,250 equals 1,200 times 1 plus 2/3 R. Now we're into our algebra. You can do this a couple of different ways. You can distribute in. You can choose to divide it out. I'm going to distribute it in just because it's cleaner on the board. That's the only reason. So we'll have 1,250 equals 1,200. That's 1,200 times 1. 2/3 of R, well, 3 goes into 1,200 400 times 2 is 800. So we get 800 R. And then we'll subtract this over. So 50 is equal to 800 R. And R is whatever 50 divided by 800 comes out to be. That would be 0.06. Now, notice it's giving us as a decimal, but we express interest rates as percentages. So we'll translate that over into a percentage of 6.25%. So if we invest our $1,200 at 6.25% after 8 months, we'll have earned $50 on that, and that'd be at $1,250.